Let's look at the chemistry of aniline. There's one way of preparing aniline, and that is from a nitrophenol. If we add tin and concentrated hydrochloric acid into a nitrophenol, we will get this compound where benzene is attached to plus NH3Cl-. Then we add dilute sodium hydroxide into this, and then we get an aniline. Normally we summarize this into one step. The reactions of aniline. I apologize for not writing this in the correct script, but here's what happens. Okay, if we were to add aqueous bromine into aniline NH2, what will happen is that it will form a white color precipitate. Actually, this is a yellow color precipitate, and here we have bromines attached to the ortho positions and the para positions. The same thing happens if we were to do the thing with aqueous chlorine, where the chlorine attaches to the ortho and para positions and form a white color precipitate. We have an aniline, we have a ketone. What happens? The O, it makes out with the two H's over here and forms water and forms this. You can identify it because of N attaches to C with a double bond. What if we have an acid halide? Well, the acid halide, this is not an acid halide. It is an acid halide actually. The acid halide, the X will go with an H. One H will still remain, and it will form this compound over here. The double bond is attached to the oxygen and the carbon, not like this. Anilines can react with allyl alkyl halides and form this. Basically the same thing, except instead of this group we get a simple R group. Yeah, acid halide is basically this group with the X, and alkyl halide is basically an alkyl group with an X. The X disappears and the R attaches to the N of the aniline. If we were to take aniline and react it with NaNO2 HCl above 10 Celsius, we will get a phenol, while if we do so below 10 Celsius, 0 to 5 Celsius ideally, we will get a diazonium salt. And that's the chemistry of aniline.